what products Würth Elektronik can offer and the advantages, some words about the market, and a question I get a lot of from customers is also about system approval, which is not directly related to the coils, but important for the system design. Let me start with two spectacular news of this year. I think you are also aware that IKEA is now offering a range of wireless charging products in their furniture or on desk. So they are also believing and stepping into the wireless power for supporting the smartphones. And coming to the smartphones, the other, let me say, impressive announcement was that the new Galaxy S6 and S6 Edge have also integrated wireless power charging capabilities. I don't know how it is in the US, but in Germany, where I live, the TV spots from Samsung, they are highlighting this feature. And this leads us to the applications. Applications where wireless charging, especially in the consumer range, is important is furniture. So imagine you have on your desk in your office, you have it in the restaurant, in the coffee shop, in the meeting room, on the airport. You find always a spot where you put your phone on and it will charge immediately, so you never run out of power. I think this is the point where we all suffer today in our daily life. Also in the car, it is really convenient when you can use the time in the car for charging your smartphone or your tablet. A little bit away from the consumer field, there are also other important fields in the industry where wireless charging transfer is beneficial. For example, in medical devices. Medical devices suffer at the moment a lot of problems with the charging contacts, which get eroded by the aggressive solvents, and the wireless power transfer offers a hermetical sealing of the device, and then it's very easy to clean and sanitize. And the same is valid also for industrial devices. A lot of devices are in harsh, wet, dirty environments and have problems with the charging contacts, and wireless power transfer can solve those problems. Another field where this technology would be beneficial is kitchen. At the moment, you have maybe also some wireless or cordless kitchen devices in your kitchen, like a kettle, but there's always this plate where you have to plug it into a power outlet. The yellow spots on this slide, they represent charging spots, and you can put the vision of cordless kitchen, which has the wireless power consortium, is that you can put any device you have in your kitchen, if it's the kettle, if it's the blender, if it's the pan, if it's the toaster or the coffee maker, you don't use them at the same time. You put them on the spot and you can use them. Even if they have no battery in it, you can directly use them with the wireless power or with the cordless kitchen appliances. Now some words about technology and standards. At the moment, commercially, there are two technologies in the market. On the left-hand side is the inductive power transfer, means the classical, you bring two coils together. One is the transmitter coil, which supports with the energy, and the receiver coil picks it up in the magnetic field. This means you take a transformer, cut it in the middle, have the primary coil as transmitter and the secondary coil as a receiver, and you have a air gap in between. The other technology is resonant power transfer, means that you have a transmitter which gives the energy with the magnetic field in the surrounding, and you have some more, you have one or more than one receivers which are tuned to the same frequency, and they can pick up the energy in that field. They share the energy, but the advantage of this technology is that you have a greater spatial freedom, and you have an easy way to charge more than one device at a time. Behind those technologies are also standards. So the one standard is the G standard of the Wireless Power Consortium. Here you see that between the transmitter, the power will be sent to the receiver, and this red arrow with load is representing the, let me say, communication between the receiver and the transmitter. So the receiver asks the transmitter for a certain power level. So the receiver can, depending on the situation the receiver is in, can ask for the appropriate power. And if, for example, the smartphone is charged completely, both devices will then go into standby. The other, let me step back, the other point to mention is that the communication of this system is also running via the transmitter and receiver coils. The Resonant approach, the Alliance for Wireless Power with the Resonance devices takes, is a different one. You have a resonant coupling at 6.78 megahertz. This is an ISM band. You see it here on the left-hand side with the transmitter resonator and the receiver resonator. But the information or the power management is running via low power Bluetooth. So this is on the right-hand side, the bidirectional communication path. So this is a little bit a different approach, has also to do with the regulations in the ISM band or usage of ISM bands. A lot of customers ask there are standards in the market, which standard should I use, or what are the advantages or the disadvantages? Let me say, last year there were 3 standards in the market. The Wireless Power Consortium with the G standard, the Alliance for Wireless Power with the Resonance, and Power Matters Alliance as the third standard. The beginning of this year, Alliance for Wireless Power and Power Matters Alliance announced that they will join forces, so they will combine their organizations and also their standard principles. I have to say that the Alliance for Wireless Power, as mentioned before, has a resonant solution, and the Power Matters Alliance has an inductive solution like the G solution. So who is behind and how many members are in? So the Wireless Power Consortium has more than 200 member companies, and a lot of those companies are contributing for improving the standard, giving the standard the next level or updates. The Alliance for Wireless Power was founded in 2012 by Samsung and Qualcomm, has 140 members, and is driven by Samsung and Qualcomm. And Power Matters Alliance was founded by Duracell PowerMet, has around 70 members. There are a lot of companies which are members in more than one of the standardizations, especially the semiconductor suppliers. They are members in all three standards. Also, Würth Elektronik is member in the Wireless Power Consortium and the Alliance for Wireless Power. When it comes to products in the market, at the moment, the Wireless Power Consortium has more than 750 certified products in the market, which includes more than 80 phones or tablets, like the Samsung I mentioned, or the Lumias from Microsoft, or Nexus 5, Nexus 7 from Google. So all major smartphone suppliers have phones which have an integrated G solution. And there are, I think, at the moment, more than 80 million units already in the market. The Alliance for Wireless Power, up to my knowledge, up to this month, they have, Chill Industries has now one FCC approved product. They still have no more products or commercial products available in the market. And PMA has around 10 products in the market. I also rate them 2 phones integrated, and those 2 phones are the Samsung S6 and Samsung S6 Edge, due to the fact that they are dual standard receivers, so you can charge those 2 phones on a G transmitter from the Wireless Power Consortium or on a PMA transmitter, because I think especially in the US there are some Starbucks which have a PMA solution offer in their coffee shops. Also, what is the idea behind? The standards are still driven by the phone and tablet requirements. So the power class is around 5 to 20 watts. Only the Wireless Power Consortium is already working on this cordless kitchen, which I mentioned before, where it goes to higher, up to 2.4 kilowatt solutions. So this is a little bit to give you an idea what's going on in standardization and what is beneficial maybe for your appliances. Now, some words to the Coil specific considerations. In wireless power, especially in the standardization, we have an important point, which is the standard, means the protocol. But another important component is the coil. And there are some effects in the coil which influence the performance of the coil. So one of the effects is the skin effect, means that the current has the tendency only to use the outer, to concentrate on the outer edge of the wire, means the eddy current leads to that behavior, means that you have a so-called dead copper in the middle of the wire. And another wire is also when you have the coil, the wire winded parallel in close to each other, the wire in the coil, you have the proximity effect, means that the eddy currents also tend to keep the current on the edge. And on the right hand side you can see the combined effect of proximity and skin effect. So this means that you don't use the complete copper for the energy transfer, and this results also in a lot of losses. You can overcome this if you use high quality Litz wire with a lot of strength. Then you can compensate those two effects, and this is done in the high performance wireless power coils. this is what, let me say, the coil supplier can influence. And now we come to a point which you as the developer of a system can influence. This is the alignment of the transmitter and receiver coil. So you can use a high-performance chipset and a high-performance coil, but you can spoil it by placing the coils not correctly or not ideal to each other. So if you have a lateral misalignment or an angular misalignment or a vertical misalignment, you can influence negatively the coupling and the efficiency of the overall system. So therefore, I always tell the customers, also in the beginning when you design this in, do not only involve the electrical engineers, also take care that also the mechanical guys and the designers are in the loop so that you place the coils in an optimal position to each other. And then another point which is important and which is taken care in all the coils, that you have a magnetic shielding. The magnetic shielding has two effects. One effect is the shielding, and the other is to increase the inductance of the coil. You see on the top left, you see a pure air coil, and the field behind is dissipated around the coil. If you then put magnetic material or a ferrite material below the coil, then you can shield and concentrate the field on the upper side of the coil. And if transmitter and receiver coil have a magnetic shielding, then you can concentrate the field between the coils, which gives you also, besides a better performance, gives you also a better behavior in EMC and EMI behavior. With the EMI, we did some measurements to demonstrate that also you can use the area behind the coil directly, for example, to put the chipset or the circuitry behind. So here you see on the right picture a system, wireless power system, where the magnetic probe is behind the coil, behind the ferrite, and we did this for 3 different coils, and we measured what the, let me say, shielding, how the emission behind the coil is. And you can see that the type 1, this means the top right coil, has the best performance with the lowest emission on the back side. And this is one of our coils with flexible ferrite or prefractured ferrite. The middle one is one with fixed ferrite, and the number 4, the lower one, is on iron powder as a shielding material. And this has the, let me say, not the best performance in shielding purposes. Then let's talk shortly about our products and what the advantages of our products are. We have all our wireless power coils are fully compliant to the G standard, and we have also some dual standard G and PMA receiver coils in our spectrum. The efficiency between the coils, we reach more than 90%. We have very good shielding characteristics for low leakage, and we have, due to the fact that we use a very high performance Litz wire, we have a very low RDC and high Q values, which are important for the efficiency and for the coupling. And a lot of people ask us, what is this with this flexible ferrite or with this pre-fractured ferrite? The advantage is, especially on the receiver side, you can do it on transmitters and receivers, but we do it mostly on the receivers due to the receivers. When you put them into mobile devices, they can get some vibrations, they can fall and get some shock, and this would then break if you take a normal ferrite material, it will break. And the pre-fractured ferrite will be put between two tapes and has a structure in it where you have some crack lines which will not influence when the ferrite should break. It will not influence electrically due to the fact that it is fixed together due to it is holded by the two foils. And so it will be mechanically break, but electrically be fully working. Würth Elektronik is the wireless power coil supplier with the broadest available spectrum for all customers. So we have currently 15 different transmitter coils and 15 receiver coils. You can find them on our website. Here are some of the new coils we have. We did a lot. Currently we released some coils, small coils for wearables. And this leads me also to the market with wearables. These are the wireless power receiver volumes like IHS sees the market. This year they see around 150 million devices in the market. It's still driven by mobile phones and tablets, and it will be driven also for the upcoming years from the volumes. But if you look at the 2017 numbers, there are roughly 100 million units which come from others, means from medical, from industrial, from all the other fields which are not directly related to smartphones and tablets. And out of this market research and also from customer discussions, we see two trends. One is going in the direction of the wearables, and the other is going in the direction of a medium power, means between 100 and 200 watts. There are a lot of applications which would like to use this technology, either in a proprietary solution or with a standard. And this year IHS gave a speech on the Wireless Power Consortium meeting, and the question was, is 2015 the breakthrough year for wireless power technology? And they said yes, due to the facts or arguments that the units shipped this year are triple the number of last year. So last year 55 million units were shipped, and for 2015 160 million are expected. This is driven clearly by smartphones and tablets. But also important is that the awareness level for wireless power doubled from last year, from 1/3 to 2/3 or to 3/4. This means they are always asking more than 1,000 people, have you heard about wireless power technology, or have you an idea what's behind that? And this number doubled from last year. So this is also now supported this year by the IKEA and Samsung announcement I mentioned before. And also on the car manufacturer side, is a lot of things are ongoing, especially here in Germany, the new BMW 7 and also the new Audi Q5 and Q7. They announced that they have a G wireless charging solution built in, and all the blue marked car makers gave an, let me say, commitment to use a Qi wireless power solution. And if you take the, let me say, global production, then those blue marked companies are representing 45% or nearly half the global production. So you see that there is a big market for in-car charging possibilities, and there is a real need because everybody is running out of power and would like to take every opportunity to charge, and at the moment you have to fiddle around with this car charging cable, and if you have a better solution, I think all of us would go for that. And the really new coming also with the Apple Watch, which also has now a wireless charging capability, the wearables, the fitness sensors, the smartwatches, there is a huge market prediction, and this is also a field where wireless power is beneficial because all these sensors and smartwatches, they communicate wirelessly via Bluetooth or WLAN and have only the charging contacts. And if you can get rid of those, you can also have more freedom in the design and in the reliability. So this is also a huge market for wireless power. Here two examples of products we have in the market with Würth solutions. One is an audio guide for museums, and the other is a professional monitor for profi sports, means football, American football or rugby, where there are a lot of sensors in that device, where you can GPS, accelerometer, heart rate, all that stuff, so the athletes can be monitored by their trainer quite closely. Are the guys moving? What is the impact the guy gets when he is stopped by the opponent player? So and they have had up to now, they had charging contacts, and now they decided to have this also wirelessly. So these are some examples from the market, what's going on, and this has also a huge impact also on the customers in the medical and industrial field. They can use the ready solution from the smartphones for their devices, so they have the advantage of the high volumes which come from the smartphones and tablets, and they have a reliable solution which they can also then easily approve. And this leads me to the last section of my presentation, the approval. The approval is not a big topic, but you have to take some things into consideration. So we are, with wireless power, we are working on a radio frequency. So the Qi and PMA solution is working between 100 kilohertz and 350 kilohertz, which is below the AM radio band. And the Resonant solution from the Alliance for Wireless Power is working on the 6.78 megahertz, which is an ISM band, which is between the AM radio and FM radio. And don't forget, we are transferring energy in that bands. So the question from, let me say, all the approval bodies is it radio or not radio? So wireless power can be rated by the mode of operation, means as a radio device. So if you transmit additionally during the energy transfer, this is the important point, if you transmit during the energy transfer on the same medium, data or music, then you are rated as a radio device. If you are only transmit energy. So the purpose of using the frequency is only to transmit energy without any signaling. Then you are rated as a non-radio device, and this means maybe a different approval. I put here some slides which I got from UL. They put those things a little bit together, and I think you are interested in the North American stuff. So how does the standardization or the, let me say, approval bodies rate this? FCC has some rules in the knowledge database so that inductive coupled devices are ruled there, and resonant devices require prior approval from FCC. So the devices can be categorized as radio devices or as ISM devices. In Canada, it's a similar approach, and the consequences are if it's rated as a radio device, FCC Part 15 Subpart C for conducted and rated emissions are valid, and in Canada, Industry Canada, RSS generation and generic and RSS 2010 are valid. Then if you put them as an ISM device, means no radio device, then you have an FCC Part 18 for ISM devices. And in Canada, you have also a similar approach from the devices that generate or use radio frequency only for energy transfer and not for data transfer. And conducted emission in this frequency spectrum between 150 kilohertz and 30 megahertz is also, the limits are specified in 18.307. And radiated emissions are also limits specified in 18.3.304.5. And in Canada, there are also the requirements on CISPR 11, which regulate all the approval stuff you have to follow. So there is stuff in. A question comes up quite often: what about the G transmission? Because the G technology or the G standard uses the coils and the, let me say, energy transfer for the protocol. And this is the exception what was reached between the Wireless Power Consortium and all these bodies, due to the fact that only the protocol runs which is directly related to the energy transfer. This is then tolerated. So therefore the chipsets are closed, so the user cannot put in or transfer their data, other data over the coils during the energy transfer. I get a lot of questions from customers. We have only a few data and it would be good to use the coils. Then I always ask, do you need the energy transfer the whole time? So if you, for example, have a slot where you don't transfer energy, then you are free to use the coils for also data transfer at a very, very lower energy level. But then you cannot do it by the wireless power chipset. You have then to put an own microcontroller, and you have to do this by your own. For the coils, it's not important, and you have only to, let me say, make sure that you don't violate these regulations. So this is the last point is the G approval, how to get a G certified product. This is only valid and you only need to make a G certification when you when the interoperability is the important point and you need those. If you because the G certification only proves or checks that the device follows the G standard, which you do when you take the chipset and the coils, and it checks the interoperability with all these more than 750 already certified products in the market. To get a G approval, you have to be member of the Wireless Power Consortium, and you have to certify your product on one of these G certified test labs, which are TÜV Rheinland, CETICOM, and DLS Electronic Systems. So this is all the stuff I know about certification, and this I think was my last slide. So I thank you very much for your interest in wireless power, and I hope we have some questions. Missy, should I go to the, let me say, chat, or will you tell me the questions?
Let's have everyone filter them through the chat, so you can send them directly to Jorg, or you can send them to Würth Elektronik's MidCom, the host, and I can forward them on to Jorg.
Okay, there are two questions in the chat. Does the control data like in G make G devices radios? I think I answered this question already. The control data only for the power transfer in the G protocol and chipset, does it not make a G device to a radio? And then I think UL certified G in Japan. Yes, there are. I only presented from the stuff for America and Canada. There are global, also in Europe, Japan, and in Asia, there are regulations which are then have to follow, but they are quite similar. Can you use the same coil for RX and TX? Yes, that's for the coil. It's not important. These let me say differentiation between RX and TX coils is artificial. It comes only from the standards due to the fact that the standards, they define the TX quite closely, but they give more freedom to the RX. But in principle, every coil can act as a transmitter or a receiver. Are there limits to scaling this technology? Scaling in terms of power level, I don't think that there are limits due to the fact that with this inductive solution, also the electrical vehicles are going with, for example, 7 or 10 kilowatts in the market. The point is that you cannot, there is some relationship between the coils area, so the receiver coil and the transmitter coil have to have a certain area, and they have some limitations from the size, which is then related to the power level. So there are some scalings in this technology, but they are related more to the device or to the application than to the technology. Which standard is better for longer distances? Clearly for longer distances, I guess you are asking for set direction, so distance between the coils. This is clearly, as mentioned before, the Resonant technology, where you can reach more freedom in that direction. Also, the G standard will have an upgrade or a resonant widening next year. This is currently, we are working in the standardization on that, so that this freedom is also then in the G standard, and the G standard has the advantage that it's backward compatible, so that products which are already out in the market now with a G solution, then you can also charge them on resonant G transmitter when they come out probably next year. Hope this answers the question. Do this kind of products be EMC compliant? Yeah, you have to take care that in the terms of FCC or CE approval, you be EMC compliant. All the, let me say, standards with the chipsets, or the reference designs, they are quite stable, and also in the standardization we take care that the EMC compliance is fulfilled. But nevertheless, if you build it in your device, you have to prove it in the approval process. Can there be multiple RX devices in the field of one TX? Yes, this is the point with the Resonant technology. So currently you can have it with the Alliance for Wireless Power solution, and with the Resonant upgrade of the G standard, this will also then offer a multiple device charging. Would sending data that is not control related through the coils during power transfer violate FCC regulations? It would not violate FCC regulations, like I mentioned before. It will force you to approve your device as a radio device, not as a non-radio device. So other rules, other FCC rules, as I mentioned before, are then valid for the approval of this device. Okay. Please provide details about under what operational conditions 93% efficiency was reached. Okay, this efficiency was reached between the coils, directly between the coils, means not overall system efficiency, and the coils were in an ideal distance, and the coils were the same size. So this means to reach the best coupling factor, you should take the same coil as a transmitter and receiver coil. So we use the same coils on both sides, and then we can reach those efficiencies. So my question is about the radiation EMI. What is the purpose for radiation EMA standard for wireless power transfer? To avoid interference with other devices or for human body safety issues? I must clearly say I'm not a specialist for EMI approval and all that stuff. I think it's both. You have to, if you bring such a wireless power system in the market, you have to make sure that human body safety issues are covered, and also the interference with other devices is under control. This means if you have inductive coupling between two coils, you normally have the field totally under control, so the emission outside, either for human bodies or for other devices, is not that big, and I don't know, or I'm not aware that any of the approved products which are in the market have any problems getting this approvals. It's a different thing when you go, for example, on a resonant solution, for example, with a distance of 1 meter between the coils. Then you have quite a big area to cover. But this is you have to take care that you do not interfere with other devices and that you do not harm any human body. So you have to fulfill those regulations on that. Is receiver combo G-PMA coil larger than a single G coil? No. This is in the same range. This is for the coil. It's only to have a certain inductance in the coil. The stuff to have a dual standard receiver is more than in the chipset. There are special chipsets which then can use or can detect if the device, for example, the Samsung phone, is put on a G transmitter or on a PMA transmitter. Then different protocols are running in a different frequency range. But for the coil, there is a certain inductance which covers both standards. Can we next question. Can we add a magnet in the center for mechanical alignment and securing connections without affecting negatively power transfer? There are already in the G standard 2 coils which have a center magnet. There are an A1, so-called A1 and A5 design which have a center magnet to, let me say, make this possible, what you are asking for mechanical alignment. But it works only with very light receivers. Smartphones are too heavy. You cannot with that magnet align a smartphone due to the fact that the magnetic force is too weak for aligning that. And you have only half the Q factor of the coil without a magnet. So you dramatically worsen the electrical performance of the system. But yes, if you have a light receiver, for example, I have a customer who has a receiver and he has his transmitter on the wall, and he would like to let the receiver hold on the transmitter on the wall, so in the vertical direction. And this customer is using the coil with the magnet because, as said, the receiver is quite light. So please send us the slides. Yes, I think Missy will take care that you get a link where you can get the slides. So let me see if this is okay here. Are high power options being developed bigger than 200 watt? Yeah, there are developed, as I mentioned, as a standard. The Wireless Power Consortium is with this cordless kitchen project working on solutions with some power classes up to 2.4 kilowatts in countries which have 240 volts. In the US it will be 1.5 kilowatt. There are proprietary solutions in the market around 200 watts, but not as a standard currently. Is there any published standard for electric vehicle wireless power transfer? Does the G standard include that? Clearly, G standard does not include electrical vehicle, as it is at the moment limited to 5 watt or 20 watt or to the upcoming 2.4 kilowatt. The electric vehicles, they are working on some standards with 3.3 kilowatts, 7 kilowatts, 12 kilowatts. I think Qualcomm with V-Power is driving a certain standardization for electrical vehicles, but we are, as Würth Elektronik, we are not active in that field. Are you making coils for A4WP standard? No, currently not, due to the fact that the standard, the first products are expected coming now in the market, and it's driven only by smartphones, and we are monitoring this. We might have some products in the market, but currently not. Okay, I think now I answered all the questions. And I think also from the time perspective, we should close this session. If other questions pop up, we will answer them also later on per email or when we distribute the slides. So again, thank you very much for your interest and have a nice day. Bye-bye.